Hello, Algebra 2. It's early morning for me, but when you wake up, you will see this. You guys are doing a packet, all right? We have a packet I'm handing out today is Thursday, 10/1. And instead of like delivering notes, I think we've kind of already done all the notes we're going to do on this section. It's just about practice. So this video is going to go over the first problem or so on each page of your packet. Be paying attention because by watching this video, you are giving yourself some extra credit if you can follow these directions. So let's get right to it, okay? I'm going to switch over to my document camera. Here is the packet for the week. First thing you need to do in order to get this extra credit is put the letter I in the top right corner. Good job, you're paying attention. This is our little secret. This says 9-5. This was not correct, it's 10-5. But this is what's expected of you here for the next little go around. So we have Friday, and then it will be due on Monday. So you have a couple days to work on. Okay, the first thing will be bell work. Okay, you'll get some bell work today, Thursday, October 1st, and you'll write your bell work in here. On the top right corner of this page, I want you to put a W. Good. We will be doing this worksheet in class today, so I'm not going to go over the nuts and bolts of it, but I want you to put an E in the top right corner of this one. Thank you for paying attention. Okay, so here's the first one. First one that you guys are expected to do on your own. We have this word problem here. Suppose a musical piece calls for an orchestra to start at fortissimo, about 90 decibels, decrease it in loudness to pianissimo, about 50 decibels, in 4 measures. That part's important. And then increase back to fortissimo in another 4 measures. The sound level, S, in decibels, that's important, of the musical piece can be modeled by the function S equals 10 times the absolute value of M minus 4 plus 50, where M is the number of measures. I had you do this on a worksheet earlier, and it's just good. We highlight the things that we think are going to be important in our word problem. First of all, the function itself, going to be important. What the letters mean is important. So anytime you see a letter in quotation marks or that they're trying to let you guys know this is going to be one of the letters and what it means, that's a good idea to highlight that. So M is the number of measures. Sound level S. S is the sound level. Okay, obviously the other numbers up here are going to be important too, but for now I think what each of the variables mean and the equation itself, that's important. Okay, now we can answer the question, what do the variables in this function mean? Ah, perfect, that's where we were. What does S mean? Well, we already wrote that, sound level. What does M mean? M is the number of measures, M. That's all you got to write. Okay. Next, what is the vertex for the given absolute value function? We learned about this in class last week, but the vertex is sitting there right in our face looking at us. Okay, there was one key thing. Can you remember what it was? When we're writing the vertex down, it will be a point, but we have to flip the sign on this one, the one that's inside the absolute value. So it's not actually a minus 4. It's actually to the right 4, positive 4, positive 50. Awesome. It said, what would the sound level be after one measure? How many decibels? Okay, well, going back to what we highlighted, the one measure, M for measure, right here in our equation, M for measure. So we're just going to plug a 1 in for M and see what it equals. So we'll start at 1 minus 4. Well, that's negative 3. Then we take the absolute value of negative 3. That's just 3. So this whole thing will just become 3. Now we're multiplying by 10, 30. And then we're adding 50. 30 plus 50, the answer will be 80. 80 decibels after one measure. Okay? If graphed, one of the points would be located at 3, 60. What does that point mean in the context of the problem? Okay, well, the 3 comes from our M, so that's the number of measures. So I'm just saying what, really putting units on this. 3 measures, 60 decibels. So we would just say after 3 measures, the sound is, bad handwriting, at 60 decibels. Easy. Just in the context of the problem, what do each number mean? What are their units? Finally then, what is the lowest sound for this musical piece? Okay, this is already given to us. We don't need to graph it. We don't need to make a table. We could. We just need to remember what the vertex is. The vertex is that point on the V shape that's at the very bottom. If it's an up-facing V, if it's a down-facing V, an upside-down V, it would be the very top. But in this case, with the way this problem is working, it's starting at some noise and it's going down, 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 and it's going up, up, up. This is going to be the lowest possible point on our absolute value equation, on our sound here for this orchestra. So they want to know what's the lowest sound level. It's the vertex. Sound level. Sound level is S. That's this part of it. Just 50 decibels. The lowest part, 50 decibels. Good. What is the measure of when the musical piece is at its lowest point? So that's asking for, we have how far down it is, but how far over did we have to get to this? What does that sound like? Answer, the other piece, the other part. We have to go over 4 to get down to the lowest. That's our vertex. So we would just say 4 measures. Finally, it says to create a table of values to display the first 9 measures of the musical piece. Show your math work below. Okay, well, they're telling us what our M's should be. Go from 0 to 8, our M's. So we can make a little table. I'll probably make it sideways because there's more room that way. But we have M and we have S. And we're plugging in from 0, 1, 2, 3, 4, 5, 6, 7, 8. It says to show your math. So this is the actual table. You're going to have to show me the math. I probably made this too big. But you have to plug these numbers in one at a time into that equation. Plug in a 0. 0 minus 4. Negative 4. Absolute value of negative 4. 4. 4 times 10, 40. 40 plus 50, 9. Okay. We learned something important here. We already have a couple of these points already in here in this problem. One is the vertex. The vertex is at 4, 50. 4, 50. So we can do that one. Here, if we were paying attention, 3, 60. 3, 60. We learned about symmetry the other day in class. Okay, was this thing, whatever happens on one side, we have this axis of symmetry, it's called. Whatever happens on one side happens on the other. There's like a mirrored effect. There's a twin brother on the other side. So if this is my middle point, if this is 60, this is 60. I would try to do it with this one, but it's 4, 1, 2, 3, 4. It looks like we can. Twin brother here, 90. Twin brother here, 90. I'll let you guys finish filling those out. You need to show me some of your math for some of those, like plug in the number. Here, I'll do it for the 3 one. So it's 10, absolute value of 3 minus 4 plus 50. So I'm just plugging a 3 in. Then it's a negative 1. The absolute value of negative 1, 1 times 10, 10 plus 50. Yeah, 10 plus 50 is 60. And that's what we're getting at. So you need to show me some math on some of these. That's it. Where were we at on our extra credit? Let's see. I need to go back to the beginning. It was I want extra credit. And our last worksheet. Please. P for please. This says, what is the standard form for absolute value? Gotta know that. Check in your notes. We have all kinds of stuff written down where this is. But y equals a, the absolute value of x minus h plus k. Okay, there's the letters. It says use those letters, and we did. I gave you a table of values already for some function, for some absolute value function, right? It's going to be a V shape. What's the vertex of the graph of the function on the table? So remember, we talked about that symmetry. We're looking for the middle. Where is the middle of that symmetry on these y's? So look, negative 5, and it goes up to negative 4, up to negative 3, up to negative 2, and then it switches down to negative 3, down to negative 4. That puts the middle right here. That's our vertex. The vertex is at the point negative 3, negative 2. How do we know? We could talk about it's in the middle. It's in the middle. Or something about it changes direction. It's on its way down, then it changes direction and goes on its way up. Anything like that is okay. As you move away from the vertex, what is happening to the y values? Okay, so here's my vertex. As I move away from my vertex, what's happening? As I move away from my vertex, what's happening? It's going from negative 2 to negative 3. It's going down. Going negative 4, it's going down. Going negative 3, negative 4, negative 5, it's going down. What's happening as you move away from the y values? They're going down. They are decreasing. So I have my vertex. I'm not really graphing it. And as I go away from my vertex, the y values are going down. Oh, okay. What does that mean about the a value in the equation? Okay, well, I just showed you guys as you go away from your vertex, if they're going down, we're getting that upside down v. What did that mean as far as the a value is concerned? I'll let you do that one. Finally, it says to write the equation for the function in the table. Okay, so now we're putting numbers in. When we're writing equations for these things, we need a number for h, k, and a. H and k we've already handled. H and k is the vertex of this thing. I'm going to put h and k where they belong then. So let's put it, I didn't give myself a lot of room, but we'll put it right here. Y equals a x minus h. If this is a minus 3, it becomes a plus 3. Remember, there's a sign flip in there. Minus 2. Almost done. So now we need a value for a. Okay? We have a point. We can pick any point we want. That's not the vertex. Pick any point we want in here and plug it in for x and y. And we could solve for k. You guys have done a bunch of worksheets like that so far. You can figure that out. There's a sneaky way. There's a trick to finding a. If you pay attention in class today, I'll give that up. I'll let you know what it is. But I'll let you put in any point you want. You could plug in -1, -4 in here and figure out what a is. Oh, yeah, this was supposed to go down here. What does that mean about the a value in the equation? We talked about that. Put it in the wrong spot. Okay, and that's it. That's number 1. So we're using a table to answer those questions. Then you use a graph to answer the same question. Get your help in class. That's it. Okay. A little introduction into each one of these. Please email me if you are stuck. Please come see me in office hours if you are stuck. Don't be miserable and don't know how to do this stuff and frustrated alone. That's what I'm here for, okay? So come contact me and let's get this stuff figured out. Peace.